Hello and welcome to helpyourmath.com. We're going to look at question 4 from the Math 206.5 Final Exam Review. It says, given f of x is equal to x squared minus 4 and g of x is equal to the square root of 3 minus x, find the following. First, the domain of f of x. Write the answer in interval notation. So the domain, f of x, is a polynomial function. It's specifically a quadratic. Any polynomial function has a domain of all real numbers. To write this in interval notation, we would say negative infinity to infinity. There are no restrictions on what we're allowed to plug in for x, right? I can plug in any real number for x, and I will get a real number output when I plug it into f of x. How about the domain of g? So the domain of g, we do have some restrictions. This is a radical, it's a square root. And what do we know about square roots? What kinds of values can we get a real number when we take the square root of them? That would be non-negative. So that means that this radicand, 3 minus x, needs to be greater than 0. 3 minus x needs to be greater than or equal to 0. Because it can be 0, right? The square root of 0 is 0. That does exist. So we say greater than or equal to. What I'm going to do is I'm just going to add x to both sides. Otherwise, I'd have to do a little bit extra manipulation. But here I would get x positive and by itself. It's just kind of on the wrong side. So we have 3 is greater than or equal to x. I'm going to rewrite that. I'm going to just turn it around to put x on the left, but when I do that, I'm going to switch that sign, so x has to be less than or equal to 3. Let's make sure this makes sense. Does it make sense that x has to be less than or equal to 3? Well, yeah, because we're subtracting it from 3, so we need things that are smaller than 3, so that way when we subtract them, we get nice big numbers. To write this, that x has to be less than or equal to 3 in interval notation, that would be from negative infinity up to positive 3, and to include 3, we use the bracket instead of the parenthesis. In part C, we're going to look at the composite function f of g of x. So this is what this means. This is a composite function. We know that this is not multiplication because multiplication would have the dot filled in. The composite function has a little open circle. So this is a composite function, and we know that f of g of x could also be rewritten as f of g of x. And what we would do is we would start with this innermost function g of x. So we would have f of, what's g of x? The square root of 3 minus x. Now what we're going to do, anywhere in f that we see an x, we're going to replace it with the square root of 3 minus x. So we would get, I'm just going to go work down here. We would get, so f of g of x will be, we're going to replace that x with the square root of 3 minus x, and then square it minus 4. Well, the square and the square root are going to cancel each other out. We're going to end up with 3 minus x minus 4, and this would be negative x minus 1, right? Because 3 minus 4 is negative 1. So we end up here, this ends up equaling negative x minus 1. What is the domain of f of g of x? Write the answer in interval notation. So the domain of a composite function consists of two things. It consists of any restrictions that the inner function, which would be g, has, and any new restrictions that would be a result of the composite function. Now, the composite function is linear. Linear functions do not have any restrictions, so that would be all real numbers, but g does have restrictions. So the domain of f of g of x will actually be the same domain as what g of x was, and the domain will be from negative infinity up to positive 3.